The Big Brain is a three-dimensional map showing the human brain in greater detail and higher resolution than ever before. Created by scientists in Germany and Canada, it shows individual sections of the brain on a molecular level, giving researchers across a range of related fields unprecedented access to the body's least understood organ. Leading the ongoing project is Dr. Katrien Amunds from the Jurlich Research Centre.
You can imagine that this 3D model of the human brain is something like Google Earth, but here we speak about Google Brain. You can zoom in, you can look to specific regions of interest and analyze these regions.
Producing the Big Brain model was a time-consuming task. After setting the healthy brain of a deceased 65-year-old female into a block of paraffin wax, it took the researchers 1,000 hours to slice and digitally image 7,400 sections of brain, each slice just 20 microns thick. The images were then uploaded to a computer, which turned them into the 3D brain model. Dr. Amunds and her team hope that through the model, disease researchers might be able to find clues to the origins of neurological disorders like Alzheimer's or Parkinson's disease.
Well, the human brain model is a tool for basic neuroscience at the very beginning, and it is clear that we need to have a profound understanding of how the brain is functioning and how it is structured before we can address questions about changes in diseases, neurological or psychiatric diseases. However, I see several aspects of application already now. So, for instance, we can measure with very high accuracy the surface of the brain and also the so-called cortical thickness. These are two parameters which are highly relevant in patients with neurodegenerative disorders, and we were not able to measure these parameters in the past with sufficient precision.
But Amunds says the 3D map is just one element in a much broader worldwide effort to learn as much as possible about the inner workings of the human brain. Scientists from 23 countries are involved in the Human Brain Project, which within 10 years hopes to replicate the anatomy, functions and cellular interactions of a healthy brain on a supercomputer for all to see.